Alright, grade 9. So this week we're moving on to resistors and resistor color codes as part of electrical systems and control. Before we move on to this and how to decode a resistor, I just want you to listen to what I have to say regarding what a resistor is, the daily use of resistors, and then the different types of resistors that we get. Okay, so firstly, what is a resistor? It says a resistor is a basic component used in most electrical circuits. Resistors play an important role in ensuring appliance functions safely and in the correct way. Okay, that's a definition for what a resistor is. In essence, anything that absorbs electricity or uses electrical current is a resistor. So any appliance, a light bulb, a heating element, a geyser, a kettle, etc., they're all referred to as resistors because they are absorbing the flow of current and then creating an output either in heat or light, etc. The four outputs that you learned about. However, some appliances do require resistors to protect them, alright? So you don't want too much electricity flowing through a certain appliance, and therefore you have to use a resistor to protect the appliance so that it does not get damaged. The daily use of resistors, it says when we toast bread, the resistor wires in the bread toaster become hot, which in turn toast the bread, alright? So the resistor wire is referred to as nichrome wire. It's able to resist a whole lot of heat, and therefore it does not break. It will get red hot, and therefore you can toast your bread. In the case of a light bulb, you switch on the light, the electricity flows through tungsten wires, and then the tungsten wire will start to glow. This is referring to olden day light bulbs. So it's not the fluorescent bulbs that we have today that have like a spiral shape. This is more the light bulb with a little filament wire inside. You may have seen it, but they are becoming quite scarce now. Shops don't sell them anymore because they do waste a lot of electricity. Remember when we spoke about outputs, the tungsten wire generates heat first before it generates light. So therefore you're wasting a lot of electricity in the form of heat. Okay, and then the last one, the point there saying an electrical appliance where the current must be controlled, we adjust the volume of a radio using a resistor. Right, so when you adjust the volume, there's a resistor that will control the amount of electricity or current flowing towards the speakers. The more current that flows, the louder the speaker would be. The same goes for people that put sound systems in their cars. If you have an amplifier, all it does is it generates a higher amount of current to the subwoofer, and therefore you get a much louder sound system. Also, with regards to the brightness of a room, some of you may in your lounge or sitting room have a dimmer switch, or you may have seen a dimmer switch where you're able to control the brightness of the lighting. So you can turn the brightness down or increase the brightness. This is used through a variable resistor. It's referred to as a variable resistor, and then you're able to control how much light is produced by turning it down. So if you turn it down, it restricts the current flow, and by turning it up, it would allow more current to flow through to the light and therefore create a brighter amount of light. Okay, so the three types of resistors that we can use. We have one, a fixed value resistor, which gives us a constant amount of resistance, and this is also referred to as a fixed value resistor, but this is more on the higher end. We have a variable resistor, which is the example I made either using a radio or using a dimmer switch. And then you have a special resistor like a photoresistor, which is a LDR, which stands for light dependent resistor. This we'll chat about a little bit later in the term, but that's pretty much a resistor that they use in solar lights in your gardens. At the school, we also have an example of this. It just helps us to switch on the spotlights as soon as the sun goes down. There's not physically someone that has to remember now to go and switch on a light or switch off the light. The LDR will then control when the light switches on and off. And the same goes for the street lights. They also make use of LDRs. It's not someone physically that has to switch the street lights on and off. Okay, so this way we move now on to the formal resistor and the resistor color code. So this is on page 72 of your textbook, and I want you to follow along with me as we work through this. So firstly, let's go through the information, and then I'm going to explain exactly how you decode a resistor. So your resistor color code, it says each resistor offers a certain amount of resistance against the flow of current, which is measured in ohms. Okay, the greater the resistance, the less current is allowed to flow through, and the amount of resistance is indicated on the component itself. Okay, this is the case for a low value resistor where the amount of resistance is indicated on the resistor itself. In this case, we are going to be looking at a high value resistor where it is broken down into four colors. So with a high value resistor, they are encoded with four color bands. As you can see here, there's 1, 2, 3, and 4. All right. The different colors have different values, and then the bands provided information about the resistance that the resistor provides, or the resistance that the resistor provides in ohms. It also gives you the tolerance, which is your accuracy of your resistor, which I'll explain as we go through this. So how the band works. The first two bands, being band 1 over here and band 2, are your first two digits that you would write down. Okay. The third band is your multiplier, so that's how many zeros you're going to add onto these first two digits. And then your last band is being your tolerance or your accuracy. So the more delicate the device, the more accurate you need your resistor to be, because you don't want it to allow any more electricity through. Okay, so how we break this down is we firstly take the first band, which is green, and we look on our table and we find green. So we can see that that's a 5. So you'd write 5 down. Okay. So I want you to take a pen now and write down 5, because we know that this is green. And if you have to pause the video, that's fine. Just go grab a pen, and then I want you to write this down with me. So we find green and we write down 5. Okay, so that's our first digit. The second band gives us our second digit. Okay, so the second band being blue, we'd go down and we find blue and we see that that is number 6. All right, so we'd write down 6. So far you'll have 5 and 6 written down. The third band is your multiplier band, okay? And in this case, it is orange. All right, so with orange, if you go down, we can see that it's 10 to the power of 3, so it means that it is 1,000. So you'd have to add 3 zeros. So you'd have 5, 6, and then add 3 zeros, okay? So that means it would be 56,000. All right? Once you write 56,000 down, you have to write ohms next to it, either in ohm, OHM, or you can make the symbol. All right, so we know that this resistor resists 56,000 ohms. Okay, and then the last band is our tolerance band. So once you've written down 56,000 ohms, then you look, this is the color gold. We move down and we see that it is 5% accurate. So then after you've written down 56,000 ohms, you'd write there 5%, and then you can say accuracy or tolerance. So therefore that means that this would resist 56,000 ohms to a 5% give or take accuracy. All right, so to work on activity 2, this is just going to be a bit of practice work. We can go through it together if we go through the first one. So if you just grab a pen or a pencil, and we look at activity 2, the very first question, number 1, page 74. It says, complete the activity by observing the figures, name the color next to the number, and give the values of the resistor. It says, use the resistor table and also color the resistor bands incorrectly. So here they've already given you the numbers, and you have to go and look for the color. So they've said to us that the first band is number 4. So we track number 4, and we'd say that it is yellow. So you'd write in yellow. Okay, the second band being 7. Right, so you look for 7, okay, and then that would be violet. Right, the third band being 2, so you'd go look for number 2, and that would be red. Right, and then red would give you 100, so you'd write down 100. And then the fourth band being 10% accuracy, and that is silver. So again, you just write in silver, and that would be the color codes. In a test and exam, you're more likely going to be asked to read it the way I taught you now, rather than giving me the colors and decoding the table. Okay, so grade 9s, please continue up until question number 5. That's all the work for this week. If you have any trouble, please feel free to email me. We will revise over this again, and there'll be more than enough time to cover everything. So take your time and work through it slowly. Make sure that you understand the principle of how to decode a resistor and know how it is done.